Hello, welcome to Data Concepts and Foundations. We will quickly explore the core ideas that make up the world of data using simple analogies and illustrations in a nutshell. Let's start with where the data originates. Every app we use, from Netflix to banking, generates data. This daily activity creates a constant stream of information that gets stored, forming the raw material for everything that we do with data. Data comes in different forms. Let's distinguish between them. Data is either structured, neatly organized like a spreadsheet or a library books, or unstructured, which is raw, chaotic like your social media post or the random notes. Structured data is easy to analyze, but the unstructured data requires more advanced tools. To understand what data is, we need to use metadata. Metadata is data about data. Just like a nutrition label tells you about food, metadata tells you about a data file. Its title, size, creation date, format, etc. It describes the data without being the data in itself. So before data can be stored, it needs a plan. That's where schema comes into place. A schema is a blueprint or a structure for your data. It defines the boxes like your name, age, and email that your data will fill in the table, ensuring there is consistency and order. How these structured pieces connect together is called data modeling actually. So data modeling is planning the rooms and the connections in a house. It defines how different tables of data like customers, orders, or product tables, they are all related to each other, creating a logical framework for your information. Once when we have this data, its reliability is key. So data quality comes into play. So data quality means your data is fresh, accurate, and correct, like your good ingredients. Poor quality data with errors or inconsistencies or duplicates is like your spoiled ingredients, leading to bad results. So cleaning up your data ensures its reliability. So the foundation and the building blocks of data are structured and unstructured data, metadata, schema, data modeling, and data quality. Now, let's see how this data is processed for different needs. So OLTP, online transaction processing, is for fast everyday tasks like a cash register processing the sales. OLAP or OLAP, online analytical processing, is for analyzing the large data sets to find patterns and trends like generating a monthly sales report. Let's explore where these large amount of data are stored. Data lake. A data lake is a vast storage area for all kinds of raw, unprocessed data in its original form, like throwing all your raw ingredients into a big bucket. It's a central repository for everything. After the raw data, we move to a more organized storage. That's where data warehouse comes into place. It's a neat, organized supermarket. Here, cleaned and structured data from the data lake is stored in an optimized, normalized way, ready for detailed reporting and analysis across the business. Now, within the supermarket, we have some specialized aisles or specialized sections. Right? A data mart is actually a smaller, specialized aisle or a section of a warehouse, like your finance only, or a sales only, or a marketing only aisle in a supermarket. It provides specific curated data for a particular department or a business functions. These are the main places where data resides. To summarize data storage, we have databases, the OLAP and OLTP for daily operations and analysis. Then we have the raw data lake and the organized data warehouse and the specialized data marts. Each serves a unique purpose in the entire data ecosystem. Having addressed the storage part of the data, how do we move and prepare these data for different systems in the ecosystem? That's where ETL comes in place. ETL stands for extract, transform, and load. You extract raw data, transform it by cleaning and organizing, and then loading it into your data warehouse. It's like turning a raw fruit into a cleaned bottled juice. ETL is a key part of your larger data pipeline. So what is the data pipeline? Data pipeline is the entire journey data takes, like water flowing through these different pipes. It covers ingestion, which is all about extracting the raw data, then processing it, which means you're transforming this data, and delivering and storing it, which means you're loading it into the data warehouse to ensure that you can get data insights from it. The speed of this data processing also varies. So, batch processing handles data in large groups, like doing laundry once a week. On the other end, stream processing deals with data continuously as it arrives in real time, like instantly cleaning up a mess. We choose either of these two based on the speed requirements. Let's see an example of a streaming data. A streaming data is a continuous real time flow of information. Think of Uber rides where the live updates are instant. It's actually crucial for applications that are needed immediate insights and responses. When data changes, we need an efficient way to capture only those updates. Change data capture (CDC) tracks only the changes made to the data rather than copying the entire dataset. If a customer updates the address, CDC captures just that change, making updates efficient across the data systems. And finally, how do we keep all of the systems aligned? This is where data synchronization comes into play, where data synchronization keeps the data consistent across different systems. If you update a customer in your CRM, synchronization ensures that the changes updated automatically in your billing systems, keeping all the information aligned and up to date. So, in a nutshell, the building blocks of data movement are ETL, data pipeline, batch versus stream processing, the streaming data, change data capture, and the data synchronization.